Hello everyone. In this video, I would like to discuss the problem E, increasing subsequences of educational code forces round 161. In this problem, it is defined that an increasing subsequence is a subsequence who is strictly increasing, right? So you are given an integer x, and you need to find an array of integers of length at most 200 such that it has exactly x increasing subsequences, or otherwise we need to report that there does not exist such array which has exactly x subsequences and whose length is less than equals to 200. Okay, this is actually a constructive problem, so let's try to find how we can solve it. So we are given an integer x, right? So initially uh, it is given in the problem statement that we can assume the empty subsequence as the increasing subsequence. So there will always be an empty subsequence, so we will decrease 1 from x. We only need to have x minus 1 non-empty subsequences in our array. Okay, so what we can do is initially let's put 1 here, right? So initially what we will do is we will put increasing numbers in our array, right? So 1 2 3 4 5 like this. So let's say we initially put at the first position we put 1, so it is contributing to exactly one subsequence. Now if we put 2 here at the second place, it is contributing exactly two subsequences. How to by contribution, what I mean is the last element of our subsequence, increasing subsequence, should be 2, and before this we can take any subset of prefix, right? So for 3 it is exactly 4. How is it 4? We will have to take the 3 in our increasing subsequence, and before this there are 4 possibilities. Either we take 1 or not take, either we take 2 or do not take in our subsequence. So there are 4 possibilities. Likewise for fourth element, let's say we take the fourth element, then before this we have exactly 8 possibilities. Either way we take any subset, we will take any subset of this prefix up to 1 2 3, right? So likewise for 5 it is contributing 16 16 subsequences, increasing subsequences. If we will take 5, and before this we have exactly 16 possibilities. Either we take 1 or not take. Similarly for 2 3 and 4, right? So there are 2 into 2 4, 4 to the 8, 8 to the 16, 16 possibilities. Similarly for 6, at the sixth position we will put 6, and this will contribute 32 subsequences. If we then put 7, it will contribute 64, right? So likewise like this we will keep on putting elements, and what we will do is decrease 1 from x minus 1, then decrease 2 from the remaining. Let's take this as remaining, r equals to this, because 1 will be empty subsequence. So r equals to x minus 1, so we will decrease 1 from r here, so r minus 1, and here we will decrease 2, then for decrease 4 8 16 32 64 128, and we will keep on inserting elements in our array and decreasing the contribution of the subsequences, right? So there will come a point where our remaining is lesser than, let's say this is n, and r is less than 2 to the power n minus 1. Okay, so this means we are not able to put n at the nth position. Why we are not able to put? Because if we put n, then our increasing number of increasing subsequences will be greater than r. So here what we need to do is we will need to put a smaller number. So from this position, how our increasing subsequence will look like. Okay, so the element from this position, this particular position, our elements will look like. Okay, so let's say we will traverse from the maximum bit of our remaining. So let's say remaining looks like this, 0 0 1 0 1 0 1. Okay, so 1 2 3 4 5. So here fifth bit is set, right? So what we will do is we will insert 6 here at the end. Why we are inserting 6? Because if we insert 6, then how many increasing subsequences is this sequence contributing? It is contributing exactly 2 to the power 5, right? Because we have 2 to the power 5 possibilities here. Then we have third bit set, right? So here we will insert 3, and similarly 1, first bit is set. So this is how we can construct our array, and we can show from this algorithm we can show that it is always possible to construct such an array which has exactly x subsequences. Okay, so for a final note, what we can say is our increasing our array will look like, first it will be 1 2 3 4 5 6 7 increasing. After this, the second part will be decreasing, and this will be just our set bits in decreasing order, right? So 4 6 3 1. Okay, so this is how we will solve our problem. Let's see the code also. I did the same thing in code also. What I did is I decrease 1 from x because of the empty we can always take an empty subsequence that will be always strictly increasing. Then I took a vector a in which I will store the elements of our array. Okay, and I will run this while loop until x is greater than 0. So what I will do is I will count the number of elements in a, then I can take 2 to the power n elements, then I have 2 to the power x to the power n possibilities. So what is n? N is the size of array, for current size of array. So I have count number so if I put an increasing number at the end of this array, then I will have count number of subsequences which is contributed by this element. Okay, if it is count is less than equals to x, then I will just insert size of a plus 1, and I will decrease count from x and continue. Otherwise, if a count is greater than equals to x, then what I will do is I will just iterate over the bits of x, set bits of x, and I will add the corresponding element of array, right? So this is all I will do here, and at the end I will print the elements of our array A. So thank you for listening. I hope you got the solution.